So now our next speaker will be Colin Brisson. He's affiliated to the Centre de Recherche sur les Civilisations de l'Asie Orientale in Paris, and he's also currently pursuing a PhD at École Pratique des Hautes Études. So he'll be talking about the Dunhuang Manuscripts as a stepping stone towards mass digitization of China's literary heritage. Colin? Yes.
Yeah, thank you very much. So I'm a PhD candidate at l'École Pratique des Hautes Études in Paris. My research focuses on the Confucian manuscripts and their interaction with other manuscripts within the Dunhuang collection. To support this analysis, I use computational tools such as this AI model that can accurately identify manuscripts that were written by the same hand. However, in light of the panel's theme, I would like to present a new perspective that I have been considering for some time. The Dunhuang manuscripts are not only invaluable historical sources, but they are also represent a unique and valuable data set to embark into the mass digitization of Chinese literary heritage. So I'm part of a team of sinologists dedicated to developing free and open tools for processing Chinese historical documents. In collaboration with the Bibliothèque nationale de France and the British Library, we have recently started working on the Chinese manuscript from the Paleo and the Stein collections. The project is led by Marc Bouy and Frédéric Constant. It has greatly benefited from the invaluable contribution from Peter Smith and Tang Wang Ward during the time at the British Library. In my presentation, I will first outline the journey that led us to the Dunhuang manuscripts, and I will then present the challenge of digitizing these documents and conclude by illustrating how they are paving the way for the mass digitization of China literary heritage. So, how extensive is this heritage? So, according to the Zhongguo Guji Zongmu, there are over 200,000 unique titles. In addition to these works, there are also several millions of archival documents, mostly from the Qing dynasty. And there is also several hundred thousands of excavated documents. Today, fewer than 10% of these 200 titles have been digitized. The challenge lies in the fact that producing high-quality digital text still requires considerable human efforts, making the process very expensive. And as a result, those who produce these texts are often reluctant to share them, rendering much of China's literary heritage inaccessible. So our question was, can we leverage the recent advance in AI to significantly reduce the costs of digitizing these documents and make them freely accessible to everyone? So the application of machine learning to digitize Chinese historical documents actually began quite early. For instance, many of you may recall the Wenyuange Sekuquanshu digitization project that launched in 1996, which was one of the earliest large-scale digitization projects in the world. Not long after, these methods were extended to the Dunhuang manuscripts. A very interesting example was presented by a team from the Chinese Academy of Science in 2019 at the IGDAR conference. The OCR performance is typically measured by the character error rate, or CER, which is the ratio of the transcription errors to the total of number of characters. So for context, the Sekuquanshu digitization project achieved an 8% CER. The team from the Chinese Academy of Science in 2019 reduced the error rate to 6%. And recently, the Chinese University of Hong Kong Library hosted a series of competitions to evaluate the state of the art. And in 2022, in 2021, the results were not very good, but in 2022, the winning team achieved a 4% CER. Despite this significant improvement, I will show you that a transcription with a 4% CER is still very impractical for many real-world applications. So the challenge stemmed from the distinctive features of the Chinese writing system. Chinese characters are visually very complex, and for AI system, it's very easy to distinguish them. It may be easier than for the Latin script. But you may be familiar with the Zipf's law, which states that the frequency of a word is twice that of the second most common word, and 3 times that of the third one, and so on. And as you can see in this graph, the pattern holds true also for classical Chinese. Because Chinese is not alphabetic, and its words are predominantly monosyllabic, the frequency distribution of characters mirrors that of words. And as a result, many characters occur very rarely. For example, the black dashed line on this graph marks the 95th percentile at rank 1492. This means that 20% of the characters account for over 95% of all occurrence in the dataset. Consequently, when an OCR system claims that a 5% error rate, actually it may only accurately recognize around 1,500 characters, which is very, very few. However, infrequent characters can be just as important. Here is an example of a transcription with a 5% error rate. I use red interrogation point to display the errors, and as you can see, the meaning of the sentence is completely lost. And such texts are entirely unusable, and yet they represent a very large proportion of the text that are currently available freely on the internet. So to tackle this challenge, we chose to perform the transcription at the line level rather than at the character level. This processing the entire line allows us to leverage contextual information, which helps to mitigate the issue of imbalanced character distribution. Line-level recognition has rarely been attempted for Chinese historical documents. This is because creating a dataset is very difficult. For alphabetical scripts, a few thousand lines may suffice. But for Chinese, for capturing enough occurrence of rare characters, it will require to annotate a very large amount of lines by hand. So instead of relying on manual annotation, what we did is that we leveraged existing transcription, in particular those from the Kansiki repository, and we matched them with the corresponding images. So this is not a trivial problem. I will not go into the details, but it's actually a very important breakthrough. Today, our dataset comprises 2 million lines from the Sekuquanshu and 4 million lines from the Songkan, which are both very large collection of books. This is maybe the largest OCR dataset for historical documents, point, and perhaps the largest ever created dataset for OCR. Thanks to this volume and diversity, our recognition models exhibits very good generalization ability. By generalization, I mean that our model can, of course, accurately transcribe familiar scripts, such as this page from the Seput Songkan. But it can also accurately transcribe scripts that it had never seen before, such, for example, as this page from the Jigjik, a Korean book that is believed to be the oldest printed work using movable types. On the quantitative level, so on the test partition of our data set, we are below 1%. When we tested on the Sekuquanshu, we are also below 1%. On the data set that was used for the competition, we are also below 1%. And on the Triptyka Koreana, as a Buddhist text collection from Korea, we are below 2%, but it's because there is mistake in the transcriptions. So actually, sometimes our model, the transcription that our model produces is good, but the transcription is not good. So the results on manuscripts are equally very promising. Even without incorporating any data from the Dunhuang Manuscript yet, our model is able to accurately transcribe this manuscript from the Paleo-Shinwa collection. Sorry. Yeah. Even with less uniform handwriting, such as this manuscript of the Analects from the Stein collection, the results remain very encouraging. Here you can see the model actually made a mistake here. there is other small mistakes, but for example, these mistakes should be solved with incorporating a little bit more data very soon. So after releasing our first set of models in 2023, we began receiving documents, image, featuring very messy handwriting, annotation, crosswords, elements that were completely absent from our training data set. And it became clear that a simple OCR solution was insufficient. We needed a comprehensive pipeline to be capable, a comprehensive pipeline to convert multi-layered inscribed objects into accurate digital facsimile. So collecting sufficient diverse data to train our system on such challenging case would have been very difficult. And fortunately, the Dunhuang manuscript, with their inherent complexity and variety, have emerged as an invaluable data set. I will now detail the work that we have done over the past few months to tackle this challenge. So first, since the Dunhuang manuscripts feature a lot of transmitted text, we plan to apply the same dataset creation method that we use on the Seput-Songkhan and the Sekut-Chuanshu. So very fast, we should be able to have a few 100,000 lines from the Dunhuang manuscripts, and we will, for sure, I'm very confident that we will go below the 1% character error rate and also on the Dunhuang manuscripts. That should be done very soon. But the 1% character error rate can be reached provided that you have good images of your manuscripts. And as Professor Rong Xingjian recently noted, despite significant advance, thanks to IDP, for example, the availability and quality of the images of the manuscript vary greatly across the institutions. Today, only a small portion of the manuscript are available as high-definition color image, and as you can see, even in the Paleo collection from the French National Library, some of the images are actually not very good. So to address this problem, we have begun training models to enhance the image resolution of the manuscripts. Our results are already very promising, and when we, for example, this is an increase by 4 of the original image, and we may be able to go even higher. We also plan to work on colorizing the image that are currently only available as in black and white. So experts in the field often say that the true challenge in automatic transcription is not, or OCR is not the transcription itself, but it's actually detecting the text inside the image. And in our case, the main difficulty was to identify very small elements, like the interlinear annotation in these manuscripts. So we developed a new system based on polygon detection to detect the text line, and by segmenting across multiple layers, we can accurately segment very small lines, as you can see in this image. This was very challenging before. Another critical issue that we had not initially considered was to determine the orientation of the text lines. So, for example, in these manuscripts, in many manuscripts, annotation or reused text maybe not follow the primary reading direction of the manuscript, and consequently, our model had to be trained to rotate the manuscript when necessary to ensure the correct text direction. And there is also a very, so there is also a huge problem is that automatic recognition system produce strings of characters along with the corresponding coordinates in the source image. However, these raw outputs are not immediately usable. We first need to convert them into text. So convert the strings into text. And to do this conversion, first we have to, since computer has no inherent understanding of the spatial relationship between the lines, we must algorithmically order them according to their natural reading order. Next, we analyze the structure of the text to distinguish between different elements, for instance, separating the main text from the annotation. And this task is also far from being trivial. And actually, we are still working on it, but we should be able to do it very soon. And our goal go even beyond simply producing well-structured text. We also aim to enrich it with annotation. And in fact, as I'm speaking, I'm participating in the competition for classical Chinese text name entity recognition, organized for the 2025 annual conference for the Nations of America chapter of ACCL. I don't know the result yet, but I can share that our system currently annotates entities such as person name, geographical location, dates, with an accuracy over 98%. So I really hope that other teams can do better, but it's actually already very high. So in conclusion, I think we should be able to finish the transcription of the Paleo collection by June. We will then start to work on the other collection, and I think that we may be able to achieve the full transcription of all the Chinese manuscripts maybe by December of this year. Thank you very much.